Next comes to revision for phenols. So what are phenol? These are also known as hydroxybenzene, and this is also a monohydric group, only one OH group. So when OH group attached to this phenyl group, this is known as your phenol. Okay, so then there are different types of phenol, but this is the phenol. If two OH group is there, then during orthohydroxy, that name is different. For meta dihydroxy, the name is different. For parahydroxy, the name is different. So here I am not going to tell about what are the names. So this is your phenol. Next, directly come how this is prepared. So this phenol is generally prepared by various methods. This is also prepared from chlorobenzene by Dawes process. So when chlorobenzene reacts with sodium hydroxide at 623 Kelvin and 200 atmospheric pressure, first it forms sodium phenoxide, which on treatment with dilute HCl forms phenol. Similarly, this phenol is also prepared from benzene sulfonic acid. So when benzene sulfonic acid fused with sodium hydroxide, it forms this sodium phenoxide, which on treatment with dilute hydrochloric acid, it forms phenol. And how this is formed? This is formed from benzene. When benzene treated with concentrated sulfuric acid, it forms this compound benzene sulfonic acid, and when it is fused with sodium hydroxide, it forms sodium phenoxide, which on acidification forms phenol. Okay, so it is also prepared from cumin. So cumin, this is generally prepared by critical reaction of benzene. Okay, so isopropyl benzene is known as isopropyl benzene. This is known as cumin, and this is on aerial oxidation in presence of air forms cumin hydroperoxide. This is cumin hydroperoxide, which on treatment with water, it forms phenol, and the side product is acetone. Okay, and this is generally prepared by reacting benzene with protein in presence of AlCl3. So this is from benzene, this is prepared, this is cumin, and cumin on aerial oxygen from cumin hydroperoxide, which on acidification or hydrolysis with water form phenol. Okay, so this is also prepared from benzene diazonium chloride, and benzene diazonium chloride this salt, when treated with water in acid medium or temperature greater than 10 degrees Celsius, when heated with temperature greater than 10 degrees Celsius, it forms phenol. So these are the methods of preparation of phenol, but commercially this is prepared by Rastrik's method. So here benzene treated with hydrochloric acid to form chlorobenzene, and this chlorobenzene again treated with water to form phenol. Okay, so these are the methods of preparation of phenol. Next, come to properties. So phenol is acidic in nature. As it is acidic in nature, because phenoxide ion is more stable. This is phenol, and after giving one H plus ion, it forms phenoxide ion. Both this phenol and phenoxide ions are your resonance stabilized, but this phenoxide ion is more stable than phenol because there is no charge separation, but here in regenerative structure there is charge separation. In this by giving one H plus ion it becomes more stable, hence phenol is acidic in nature. So this acidic character also depends on different factor. I will discuss later. Okay, so this in this this is acidic, it turns blue litmus red, and this is soluble in sodium hydroxide. This is soluble in alkali, but this is less acidic than that of carbonic acid. Phenol is also known as carbolic acid, and this is less acidic than carbonic acid. In this way, it cannot liberate carbon dioxide gas from carbonic acids. Okay. These are also less acidic than carboxylic acids. Carbonic acid, carbonic acid, then carboxylic acids. Okay. Next, it reacts with phenol, reacts with sodium metal to form sodium phenoxide. It reacts with alkali to form sodium phenoxide. Okay, it is dissolved in alkali. Next, this phenol is actually this O and this carbon, oxygen carbon has somehow double bond character, and here in this bond breaking do not take place here easily. So in some drastic condition, in some cases only bond breaking takes place here. In this phenol do not undergo nucleophilic substitution reaction easily. However, when phenol reacts with ammonia in presence of at high temperature, when heated with ammonia at high temperature about 523 Kelvin, in presence of ZnCl2 zinc chloride, it undergo nucleophilic substitution reaction to form aniline. Okay, so phenol, so this phenol is generally this group OH group, due to presence of this lone pair electron, due to presence of this lone pair of electron, this phenol generally undergo electrophilic substitution reaction. Generally phenol undergo electrophilic substitution reaction. When reacts with bromine water, it forms 2,4,6 tribromophenol. This is a white precipitate. 2,4,6 tribromophenol. But when treated with bromine in presence of carbon disulfide, it forms mixture of orthobromo and parabromophenol. Orthobromo and parabromophenol. Okay. Similarly, phenol reacts with dilute nitric acid. It reacts with dilute nitric acid to form orthonitrophenol and paranitrophenol. Para is more predominant product, but when treated with concentrated nitric acid in presence of concentrated sulfuric acid, it forms 2,4,6 trinitrophenol, also known as picric acid. Okay, phenol also treated with when heated with concentrated sulfuric acid, it forms orthohydroxybenzene sulfonic acid plus parahydroxybenzene sulfonic acid. In this way, it gives you different products. Okay, so these are the reaction of halogenation, then reaction nitration, then sulfonation of these reactions. Next, phenol when treated with neutral ferrichloride, it forms, so when it treated with neutral ferrichloride, it forms a complex. So in this way, it forms a complex having violet color soluble complex. Okay, phenol also undergo esterification when reacts with alcohol. So when reacts with acids. So phenol when treated with acetyl chloride, when treated with acetyl chloride or acetic anhydride, so when acetyl chloride reacts in presence of pyridine, when acetic anhydride it reacts in presence of some sulfuric acid. In presence of sulfuric acid, it undergoes esterification to form OCOCH3. In this case also forms this compound, and this is called phenyl acetate. And when this phenyl acetate heated with in presence of aluminum chloride, it undergo isomerization to form orthohydroxyacetophenol and para-hydroxyacetophenol. This reaction is known as Fries rearrangement reaction. Okay, so this reaction is known as Fries rearrangement reaction. And phenol also reacts with benzoyl chloride to form that is phenyl benzoate. It also reacts with benzoyl chloride to form phenyl benzoate. This reaction is known as Schotten-Baumann reaction. This is known as Schotten-Baumann reaction. Next, some important reactions, some special reactions of phenol is that is Reimert-Tiemann reaction, Coles reaction or Coles-Kim reaction. So this phenol, just by hints I am writing, when treated with chloroform in presence of sodium hydroxide at 340 Kelvin and followed by acidification, it forms orthohydroxybenzaldehyde known as salicyl aldehyde. And similarly, when it treated with carbon tetrachloride in presence of sodium hydroxide, so the ratio number of sodium hydroxide, the moles of sodium hydroxide is different, here 3 and here 4, it forms orthohydroxybenzoic acid also known as salicylic acid. So this reaction is known as Reimert-Tiemann reaction. Similarly, phenol treated with sodium first forms sodium phenoxide, and this sodium phenoxide when treated with carbon dioxide at 4 to 7 at 400 Kelvin and 4 to 7 atmospheric pressure, first it forms sodium salt of this compound, and this undergo rearrangement to form sodium salicylate, which on acidification forms salicylic acid. So this reaction is known as Coles reaction or Coles-Kim reaction. Similarly, phenol reacts with benzene diazonium chloride. Phenol reacts with benzene diazonium chloride in slightly alkaline medium at ice cold temperature to form an orange dye that is para-hydroxyazobenzene is formed, and this is known as coupling reaction. Similarly, phenol reacts with phthalic anhydride in presence of concentrated sulfuric acid to form phenolphthalein, which gives pink color with alkaline medium. So phenol when treated with phthalic anhydride in presence of concentrated sulfuric acid, it forms phenolphthalein, and phenolphthalein is colorless in acid medium and pink color in alkaline medium. So phenol treated with suppose I am writing here OH, H, your OH, H, and phthalic anhydride so this reacts in presence of concentrated H2SO4 to form so this is phenolphthalein, and phenolphthalein is colorless in acid medium and pink color in alkaline medium. So next come to what is the acidic effect of substituents on the acidic strength of phenol. So you know this phenol is acidic due to its different resonating structures. So but the presence of electron withdrawing group like NO2, CN group, etc. increases the acidic strength. This increases the acidic strength, while if these are present at para position, increases more than that of at meta position. So the electron withdrawal, the acid strengthening effect is more effective at para position than at meta position. Similarly, electron releasing group like NH2 group, like CH3 group, methyl group, etc. This decrease the acidic strength. And this acid decreasing effect is also more effective at para position than at meta position. Okay, so in this presence of nitro group increases the acidic strength of phenol, and presence of methyl group decreases the acidic strength of phenol. And there are also different electron withdrawing groups which also increase, these increases the acidic strength, while presence of electron releasing group that intensifies the negative charge here. In this way, this decreases the acidic strength of phenol. Okay, and this phenol also reacts with formaldehyde to form the polymer bakelite. This is also used for preparation of various antiseptics. Okay, so this is a quick revision about phenol. Next come to ethers. So what are ethers? Ethers are dialkyl oxygen compounds. So these are the alkyl derivatives of alcohol. These are the alkyl, alcohol ROH, and this is ROR. So in this these are the alkyl derivative of, we can say alkyl derivative of alcohols. Okay. So a dialkyl derivative, we can say dialkyl derivative of water. These are the dialkyl derivative of water. There is a presence of oxygen with 2 lone pair of electron, and this is here the divalent oxygen is there. And generally ethers are prepared by various methods. So this is prepared from alcohol. So when an alcohol heated with concentrated sulfuric acid at 413 Kelvin, it gives an ether. Okay, it is also prepared from alcohol by heating with aluminum oxide at 523 Kelvin. It also forms ether. Okay, so this ether also prepared from alkyl halide. So when alkyl halide heated with dry silver oxide, when alkyl halide treated with dry silver oxide, it also forms ether. If both the alkyl groups are same, these are called symmetrical ether. If both the alkyl groups are different, one of them is different, then this is known as your unsymmetrical ether. Here in this method from alkyl halide, only symmetrical ether is formed. But both symmetrical and unsymmetrical ether can be prepared by Williamson's synthesis. Both symmetrical and unsymmetrical ether can be prepared by Williamson's synthesis. Okay, so what is when an alkyl halide reacts with or when a sodium salt of alcohol, that is sodium alkoxide, sodium salt or potassium salt of alcohol treated with an alkyl halide. So when these are treated, it forms. So in this method, both symmetrical and unsymmetrical ethers can be formed. So for example, okay, so this is your ethyl methyl ether. In this way this can be formed. But remember, if one of the alkyl group is tertiary butyl and another group is a primary alkyl, so generally the primary group contains your halogen and the tertiary group contains the sodium salt. So CH3 whole twice CONA plus C2H5I. So the tertiary group contains the sodium salt and the primary group contains this halogen, so that it will form tertiary butyl and ethyl ether. But if we change the halogen and sodium salt different, if we take the sodium ethoxide and here halogen is attached, at that time it will form an alkene instead of ether. So in this way, for tertiary butyl group, it should contain sodium salt and the primary carbon group, that should contain this halogen. Similarly, in case of aromatic ether, generally sodium salt of phenol is taken. Sodium salts of phenol, that is sodium phenoxide, and alkyl halide is taken, because the carbon and halogen bond in case of this phenyl group does not take place. The breaking of this bond do not take place easily. In this way, it forms. Okay, it forms your anisole. For the preparation of anisole, this methyl group should contain a halogen group and this phenoxide group should contain, and this phenyl group should contain this sodium salt. Okay, so this is the methods of preparation of ethers. Next come to properties. Properties. So due to presence of lone pair of electrons, this ethers acts as Lewis bases. In this way, it forms complexes with Grignard's reagent, with BF3, with AlCl3. So maximum organic reaction using this takes place by using this Grignard's reagent as solvent. These are Lewis bases. These are also soluble in concentrated hydrochloric acid and concentrated sulfuric acid. These are also soluble in this. So they form salt with HCl and H2SO4. Okay. So this ethers reaction, another chemical properties. So this ethers reacts with halogen acids, and when heated with halogen acids, it forms alcohol and alkyl halide. Remember, when this bond breaking takes place, always generally the smaller alkyl group contain halogen. The smaller alkyl group contain halogen. Okay, smaller alkyl group contain halogen and the larger group contain alcohol. Larger alkyl group forms generally alcohol. But in case of tertiary butyl, if you take tertiary butyl and ethyl ether, and here HI is taken, but in this case it depends on the stability of this carbocation, and the tertiary carbocation is more stable. Here this is the general case, but there are some special cases. If the tertiary alkyl group when treated with this, also benzyl group is there, benzyl ether is there, and when HI is there, then this halogen is attached to this benzyl group and this tertiary butyl group. CH3, C, CH3, CH3I plus C2H5OH. In this case also C6H5 CH2I plus C2H5OH. So in general this one, but these are the special cases. Similarly, in case of phenyl ethers, plus HI, if here this bond breaking takes place, then it will form phenoxide, phenol, it forms phenol plus. Okay, so all this depend on the stability of carbocation. Okay, as this depends on this SN1 mechanism and this preparation depends on SN2 mechanism. In this way, the properties vary. Next, this ether, diethyl ether, when reacts with acid chloride in presence of zinc chloride, it forms an ester. Similarly, it reacts with acetic anhydride in presence of ZnCl2 to form 2 moles of ester. And when this reacts with halogen in dark, it forms mono-substituted product. In one step, in another step, your alpha halo and alpha dash. But when treated with chlorine in presence of light excess, and this excess of chlorine in presence of light, then all the hydrogen atoms are replaced by halogens. This is called perchloroether. Okay, so when this ether undergo aerial oxidation, when it undergo oxidation in presence of light, then it forms peroxide. This form peroxide, and these peroxides are generally used as explosives. Okay, so this is also a quick revision about ethers. Okay, next one question, how this diethyl ether is formed and what happens when this diethyl ether reacts with acetyl chloride or acetic anhydride or chlorine in presence of this. Okay, so these are the properties of these some aliphatic ethers. Next come to examples of some properties of some aromatic ethers. So aromatic ethers, here I am taking the example of anisole, and when this anisole, so there is presence of lone pair of electron, so due to this is ortho-para directing nature, but the para isomer is more more stable than that of ortho isomer. The para product is the major product than the ortho product. So it reacts with nitric acid, it forms para nitro anisole along with a small amount of ortho nitro anisole. Similarly, it reacts with CH3Cl in presence of AlCl3 to field cut reaction. It forms para methyl anisole and ortho methyl anisole. Similarly, it reacts with concentrated sulfuric acid to form para-methoxy benzene sulfonic acid and para-methoxy benzene sulfonic acid and ortho-methoxy benzene sulfonic acid. Okay. Similarly, in this halogenation also takes place, and it falls from para form and ortho form, but this para form is more stable than that of ortho form. So these are also a quick revision about ethers.